Okay, we're going to take a look at some really basic ideas about graphs in just a second. Before we do, we're going to talk about a topic called the average rate of change. It's really simple. You usually see this in a section about lines, but we're going to talk about it real quick. The average rate of change is just not all functions. Let's see what we got here. Do we have something better? Well, let me just make my own. Okay, so suppose we had a picture. So we have a graph. In the real world, a lot of things can be modeled by mathematics. So there might be something that happens in your business where perhaps these are years, and this x squared function, this quadratic function, is a good indicator of what your business sales look like or your expenses or something like that. And what we'd like to know, like suppose this was year 2000, this was 2010. We'd like to know how things have been changing between these two places. Well, changing, the average change, we've seen before, it's just the slope. So if it were a line, we know the slope is the average rate of change, up and over, up and over. Well, if we want the average rate of change, but the function itself is not a line, all we need to do is make a line between the 2 points we're interested in. So if I want to know the average rate of change between 2000 and 2010, what I'm going to do is I'm going to use the 2 points off the graph. So we'll show you this on the next one, but I'm going to use this point here. It's got an x, it's got a y. I'm going to use this point here. It's got an x, it's got a y. And I'm going to just take the slope of that line that would be created, and that's the average rate of change. So they're looking for, looks like the average rate of change between 2005 and 2012. Okay, well this is a point. I don't like the notation they've used here at all. So, but here's the point. This is, yeah, I don't want to think of it. We want to think of it as x's and y's. Let's see what they do next. So we're just going to find the slope between them. There's changes of x's. So here, which is terrible about this, here's my x is the years. My y's are what comes out of the function. Okay, now they've switched it here. 2007, 2009. Is this the same example? 2007, 2009. So we're just going to use the slope formula. That's all it is. So I'm taking my two y values, which are the prices of the gasoline in the 2 different years, and we're going to check the average rate of change. And this is very amusing because supposing to this, so this is just the slope between these 2 points, and theoretically the price of gas has gone down 22 cents per year. I don't know about that. Okay, so we would do this again with 2005 and 2010. So we need to go back to our table here. So I need to write these down because I have no way to carry them over to the other screen. All right, so in 2010, I got 2.84. I think, what was I going to next? 2005. So in 2005, I had 2.31. All right, let's go and now actually work it. So if we're here, I'm using just y2 minus y1 over x2 minus x1. So here were my points. I had 2010 and $2.84, I believe. 2005, I had $2.31. Okay, so let's see. I'm going to take my second y. I'm going to use this one as my second point because of the year. So 2.84 minus 2.31. Now on the bottom I'm taking my x's, just don't flip it. I'm using this as my x2, 2010 minus 2005. So just the slope formula, that's all it is. Okay, now I'm going to crunch this on my calculator. So I'm doing 0.53 divided by 5. So just working these, and I got 0.106. So the average rate of change of gasoline between the years 2005 and 2010 is it went up on average about 11 cents. Okay, now this is a way they will show us this. This notation means that we want to find the average rate of change from -1. These are two x's because they're brackets. It's not parentheses. So they're saying, I want you to go from -1 to 2. So we're going to be working with the point there, and we're going to be working with the point here. So those are two x values, and I just want to find the slope between them. Okay, that's a confusing screen. So yeah, that is a really confusing screen. All we're doing is we're finding the points. Let me show you. So I have the point -1, 4, and I have the point 2, 1. And I'm just going to put it in the slope formula, which they've done here. The average rate of change between those two is -1. On average, it's going down by -1. As x changes by 1, it's going down by 1. Okay, so more of the same here. It's the same thing. So what are we doing here? I don't even know where it's saying. What? Oh, 6 hours or something? Well, I don't know. Yeah, I don't even know where the question's being asked. But so over 6 hours, what's the rate of change? So we're using this point 6, 292, and this point 0, 10, finding the slope, and that's our average rate of change. Okay, this just keeps going on. There's supposed to be 1 over x down there, I believe. All right, so they've given you the function, but they didn't give you the graph. Now these are two x's, so what I'm going to do is I need to find these two values. So do you know this notation? It just means I'm going to put 2 into the equation, and find what comes out. And when I do, I'll now have points. Right now I don't have the points. I have the x's, but I got to plug it in to find the y's. And have they done this for us? Yeah, so this one turns out to be 63 over 4, and this one is 7 halves. So we crunch it. Now, here's the points that we have. 2, 7 halves, 4, 63 over 4. We just had to find the y values. We had the x's. Now, this math isn't very much fun, but you would find the average rate of change. It's the slope here. So here they are, just plugging it in the slope formula. Do a lot of fraction math. You get this. Okay. So I have the x coordinates, but I don't have the y. So I'm going to plug them in. You don't have to show all this. I just want you to see it that these are a pair, an ordered pair. So I've got, plugging it in here, I get 1 minus 2 square root of 1. Down here I get 9 minus 2 square root of 9. Okay, so if you just do the order of operations on this, I'm going to get 1 minus 2 is -1. Down here I'm going to get 3, I get 3. So I now have these 2 points, 1, -1, and 9, 3. We just need to find the slope. So y2 minus y1, x2 minus x1. So my average rate of change is 1/2. Okay, this just keeps going and going here. Yeah, it's the same. So same thing. Just look what they've done. We're trying to get, those are my x's, 2 and 6. I need to get the y's that go with it. So we're just crunching it. So they've just plugged 2 into the formula. They didn't even show it. Oh, here it is. That's what you'd get out. They plug 6 in the formula. Oh, the other way around. I'm sorry. 2 goes in, gets you this. 6 goes in, gets you this. And then it's just the slope. Same thing. Sorry, that's confusing looking, and I didn't say it really well, but that's all there is. All right, there's a bunch of these. Sometimes you can do the average rate of change, and you're doing it with an I don't know. This is an idea that's going to be helpful to us if you get to calculus. I'm going from 0 to a. Well, I can't solve a. It's just an I don't know. But we'll work it even though we're not sure what it would be. So if I put 0 in here, I would get the point 0, 1. You see I'm putting 0 in here. Let's put a in here. Well, you'd get the point a squared plus 3a plus 1. Now I know that's very odd, I agree, but these are points, and we're going to leave it with this I don't know in there. So if I were to crunch this, here's my y2 minus y1. Yeah, there it is. That's all. They try to do it all at one time. Not helpful. y2 minus y1, x2 minus x1. And you tidy it up, you get this. Now, they're jumping steps here. They pulled out a GCF so they could cancel the A's. All right, let's take a look at this. I'm going to make my points 5 and A are my points. So if I put 5 in here, I'm going to get 5 squared is 25, plus 2 times 5 is 10, minus 8. So I've got 35 minus 8, 27. All right, now I can't do any better than just putting A in here, and I'll get A squared plus 2A minus 8. All right, now let's do the rate of change. So y2 minus y1, x2 minus x1. All right, so we have this now. This can be factored up here, which is where they're going with that. So I've got A plus 7, A minus 5. Hopefully you're not rusty on your factoring skills there. Cancel, cancel. Get A plus 7. All right, now here is where we're going to start taking a look at what graphs look like. I think you're going to find this pretty simple. So first we need a couple terms here. A local minimum is a valley. If I were to start driving a car, we go left to right in math. We're going to drive just like we read. So we go left to right. I'm going to read left to right. I'm going to go on my number line left to right. So I'm going to drive on this graph. Now remember, the arrows mean it goes on forever. So if I'm driving a car on this graph going across, local minima are valleys. They're the bottom points. That is a local minimum. And the top of a valley is a local maxima. So here's another minima. So I'm driving along and I'd be hit at the bottom of the valley, get the top of the hill, bottom of the valley, and I keep right on going. Okay, so those are called the minima and the maxima. Now they're called local min and max. We'll talk more about that later. But next is, where were we going downhill and when were we going uphill? So here they're asking us, when are we increasing? So we were going down, we were going down, we were going down until we got here. Now they want increasing, and we're going to put this in terms, it's just like we did with the domain. We want it in terms of only the x. So I was going downhill till I got to 1, and then from 1 all the way to the top of the hill at 3, I was going uphill. Now I go downhill again for a while, then from 4 to infinity, I went uphill. Now notice I'm using parentheses here because at 3 or at 4, I'm at a bottom point. I'm actually not going up or down. I've hit the valley. I've stopped. So we don't want brackets. We want parentheses. Okay. So this function has been graphed for us here, and they want us to say the minimums and maximums. This is not a good question. So very difficult question here. So I think what their point is that yeah, this is not a good question to start with. I wish I had another one without this. Yeah, forget those. I don't want those. So let's jump to this here. We want this time, here's what I want. We're going to tell where it's increasing, where it's decreasing, and I want the coordinates of the local maximas and the local minimas. So let's start with those. So I have a max atop of a hill at the point 1, 2. I've got a minimum at the point -1, negative, their scale is off here. Ugh, it's going to make me do all that again. Sorry, everyone. Okay, so We were first finding the min and the max. So I'm at a bottom of a hill at the point -1, at a point -1, -2. I was at the top of a hill at this point, 1, 2. Okay, now let's do the interval where it's increasing and the interval where it's decreasing. Now remember, we were driving our car from left to right. So as we start off here, we are decreasing all the way. Now it's only the x's. I'm decreasing along the x-axis from -∞ to -1. Okay, now we start increasing, so I'll jump up to the other one. From -1 to 1. Do you see as I move along here, I'm increasing? Now, from 1 to infinity, I'm decreasing again. So one more time, because I don't know how many of these I have. I've got local maximum, a high point here at 1, 2. Got a minimum at -1, 2. Now as we move left to right, we were going downhill along. But I only care about the x values. I was going downhill from -∞ to -1. Going uphill from -1 to 1. Going downhill again from 1 to infinity. Okay, I'm hoping I have some more of those in the next video, but that should get you started. What we saw there is the average rate of change is just the slope between any 2 points. You just do y2 minus y1 or x2 minus x1. And then local maximas are the tops of the hills, local minimas are the bottom. And then we want to see where we're increasing or decreasing, but all we care about is how that is on the x. Like we write that like a domain, we're going to write just the x values that are increasing and the y value and the x values that are decreasing.